RHS Pre-Calculus presents Aviation Man Saves a Day.
One day in the city of Metropolis, a cry for help was heard. Who could save the day but Aviation Man? The only problem was, Aviation Man was in a different city. He needed to fly back to Metropolis and help the citizen in need. He took off, flying due east at a ground speed of 110 knots. The only problem was a side wind from 8 degrees east of south, blowing at 20 knots. To arrive at his destination, safe and sound, he needs to calculate his wind correction angle. Do you know how? No? Well, let us show you.
As shown by the diagram, the wind is blowing towards the origin and against our hero. To work out the angle of the headwind from Aviation Man's original course, let's draw the wind on the coordinate plane. By drawing a line from north to south on the end of Aviation Man's original course, we can then draw an angle 8 degrees east of south. As we know that the angle formed by the vertical and horizontal lines is 90 degrees, and the second angle is 8 degrees, by adding these two angles, we can see that the angle at the top of the triangle is 98 degrees.
As we know that the angle on the top of the triangle is 98 degrees, and that the speeds of Aviation Man and the wind are 110 knots and 20 knots respectively, we can then use the law of cosines to solve for the third side.
The law of cosine states a squared equals b squared plus c squared minus 2bc times the cosine of a. By plugging all the relevant values into the law of cosines, we get a squared equals 110 squared plus 20 squared minus 2 times 110 times 20 times the cosine of 98. This simplifies down to the square root of 13,112.362, which in turn comes out to be 114.51 knots. From there, we can use the law of sines to calculate the wind correction angle. The law of sines states sine of A over side length A is equal to sine of angle B over side length B. The sine of, by plugging in the relevant values, we get the sine of 98 degrees is over 114.51 degrees is equal to the sine of x degrees over 20. This, when we try and solve for it, we get x equals the sine inverse of 0.173, which comes out to be 9.96 degrees. In order to find that in terms of degrees from north, 9.96 degrees must be added to 90 degrees. After doing this, we can see that the final wind correction angle is 99.96 degrees east of north. In order to save the citizen, Aviation Man needs to account for this change in direction by flying at the angle of 99.96 degrees. If he does, and solves his math problems correctly, the citizen will be saved and his superpowers will remain intact. Can he do it? Will the citizen be saved? Tune in next week for the thrilling conclusion.